Let's learn about velocity time graph. What goes along x and y axis in a velocity time graph? Along the x axis, we have time that goes along the axis, and along the y axis, we have the velocity. So this makes up a velocity time graph. I should have told in the other way around so that you guys remember. So along the y-axis it's velocity, and along the x-axis it's time. So it's always y and then x. So let's look into different cases. How does an object which is at rest look in a velocity time graph? That's the question. So say this is your velocity time graph. So the velocity goes along the velocity goes along the y-axis and time goes along the x-axis. So if an object is at rest, how will it look? Let me show it to you. So I'm making the speed and acceleration and everything 0. So you'll understand all of this in time. So I'll just show it to you in this way. So can you see that? The dot, that arrow is not moving. So let me end the program. So let's see. We have distance time graph. The distance is neither increasing nor decreasing, means the object is not moving. So how will the velocity look? The velocity is 0. It's along the x-axis. So basically over here we have the velocity to be along the x-axis. Okay, so if this is a velocity expressed as meter per second, so we have it to be on the x-axis from 0 to t. Now next thing is, if an object is under uniform motion, how will it look under velocity time graph? So with this we'll revise the distance time graph also. That would be helpful. So let's look at a scenario wherein the object is not accelerating. So what does that mean? Again, in time I'll make you guys understand, but it has a speed. So you can see all of this distance would be same. You can take a scale and measure it. All of this distance would be same. Let me terminate this. So you can see over here the distance is, for every 2 seconds a distance of 100 meters is covered. So 2 to 4, it moved from 100 to 200. So difference is 100 meters. For every 2 seconds it got displaced by 100 meters. So this is equal distance in equal interval of time, and the velocity happens to be 50 throughout. Can you see that? So under velocity time graph we can see that it's a line parallel to x-axis, but it has a particular value, unlike this particular scenario which was on the x-axis itself, but here it's not so. It would be parallel to x-axis, but it will have some a meter per second value. Okay, it can be negative also. That is something that we won't talk about. And last we have object at non-uniform motion. Quite simple to guess, make a guess how it might look. So it would be covering unequal distance in equal interval of time. Can you see that? So this is unequal distance in equal interval of time. So every second it is covering whatever distance you are looking at. And let's look at the, okay, I didn't stop it. Now let's look at the graph. So you can clearly see the distance is increasing and decreasing and all of that, and the velocity here increase then decreasing. So this is non-uniform velocity. right? So this can be categorized as non-uniform motion. So we have increasing, decreasing, parallel to the x-axis, all of this scenario, any of this scenario combination, any combination over here, it is said to be, yes, non-uniform motion. And this is velocity under meter per second. So this is your non-uniform motion. So this, all of these cases, you guys have to remember this and understand it. More than remember, you need to understand it. Drawing on your own won't be that difficult. So understand the heading and the respective graphs. Of course, you guys need to make use of this. How to enter different values over here, it's something that we will understand. I would, of course, I will fine tune this. There are a lot of things to be kind of retyped and make it a bit more obvious, and a lot more explanation in all the programs actually. So that also I will be doing. But you have to make use of this. Try to execute it. Okay, put in different values and have a look at the graph and what is happening with the distance, displacement, velocity, and acceleration. Okay, so that's how you can understand the concept and the graph better.